Do 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 do. Do 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 do. Right, Shenzhen. ShenZhen.io. This looks amaze balls. I have to say, I am very, very excited about giving this game a go. Looking forward to just starting up, just making sure everything's working and the stream is working and all of those things are happening. They seem to be, so that's good. Hey Nassim, welcome. Last time we had a stream, there was a kind of problem with the data rate and all of those things, so hopefully it's going to work okay. Just getting settled now, so I've just literally loaded up the game. I'm going to quieten the game music, so hopefully the audio's right. Let me know. Okay, good. So Shenzhen, Hawaii Zanbei District, Cam 4 Live, weather heavy rain. So concept mail, datasheets, control panel. So I guess this is like your computer tablet. So I'm going to go to mail. Oh, it's got reading in it. Right, I'm going to shift up here. Thank you for joining Shenzhen Longteng Electronics Limited. We aim to be a blah 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 diligence. This literally reads like actual real email. How's my day going? Pretty good. It's a bit chilly here. So I've got my warm coffee. So I'm just trying to see here. This product is an imitation mock security camera. It has two blinking lights. The first blinks the regular pattern. The second light is an internet light, so it should be blinking more random. As you'll notice, the design is partially complete already. The previous engineer left before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those as the expected values indicated. So, okay, so there's your CAD program. Do some LoRa stuff. Yeah, I should do some LoRa stuff. One day, but not today. By the way, I don't like how this chat pane is mashing up the whole OBS window. So if anybody knows how to format the YouTube chat pane, I'll certainly be interested in trying your CSS for that. So open the design. Do I have to choose it? Right. Gosh, so this looks like the circuit. So we have move 0 to register P0, sleep for 6, move 100 to P0, sleep for 6. And then there's some comments, the guy saying, why is this so hard? So Nassim, this is called ShenZhen I. Network. Okay, so we need to, let's do a test run. How do we start? So there's the signals. So this is what you should be trying to achieve, and we're going to push play. No good. This is literally like real life. Oh my word. So is this so this is their CPU. So you've got a CPU that's at 3 yen basically. They're saying this is what that is. Okay, so they were hooking it up, the P0 input from the network source. So this is the LED. Okay, got you. Now I did see data sheets somewhere. Oh my word. Datasheets has opened something in my actual web browser. It is an actual datasheet for the game. Oh my word, like a real datasheet. Look, there's a reference design here as well. That's phenomenal. Okay. I think you could just playing this game probably start to give you an idea of how to learn about it. It's got virtual CPU basically. So this is the virtual CPU of its machine code language. Square wave generator. So the IO pin is P1, that's what that is. Oh, I see, so that's an IO pin. Okay, well let's just play with it a little bit. I'll keep this data sheet open in another window if I need it. Right, how do we go back to the thing? That one? Strange that you'd have to go to your email interface to get back to the camera. Okay. So its state is sleep. So this move 100 to P1 is not working, so that's the problem. So that's the bit that needs exploring. So to get back to my data sheet, there we go. So move 100 to P1, it moves 0 to P1. That should be what's sending an output. I'm assuming P1 is a general purpose I/O. They're using P0 on their design. So I think you have to use P1 because of the shape. You're trying to fit it into this same enclosure. Nassim, I don't think you're the only one here. It says there's 6 watching. I should probably shout out about it on Twitter and the like, but actually, look, you can see this. This has illuminated. So it is energizing. I'm not seeing down here. Anyway, let's not worry about that. So just typing in sleep for 3, I think. P0. Sleep for 2. P0. Sleep for 1. Move 100. P0. Sleep for 1. Something like that. Okay. Yuri, look, this game is insanely cool. It's like a thinking game, like a puzzle. I do realise, by the way, the chat window, I'm going to maybe move it over to the left because there's a bar on the right here which shows you all of the hardware you can use. Show profiler, hide profile. Look, it's crazy. But I'm seeing this simulation, but I don't know how you... Oh, I see. Okay, now you can see what's going on. So the first circuit, which was the top one, which is just the simple LED emulator, that was working because it was just working right. But on the bottom one, you can see where my one is slightly out. Yeah, that it's showing you it in red. So that's good. Okay, I thought it'd show a separate trace on the bottom. That's absolutely fine then. Fine by me. I'm happy with that. I think this should do it. Hey! Booyakasha! This is ShenZhen.io and boom! Yeah, Yuri, it's exactly like designing a PCB. And just for those who've literally just stepped in, look, you actually have data sheets on the virtual components here. So you need to learn, look, this is the actual chip. Look, this is a virtual CPU, this MC XXX family, and it has a whole machine code instruction set. So yeah, definitely my kind of game. Right, so your boss says, thanks for the prompt work, looks okay, hooray! Our Factory 4 has some examples of older equipment that require control signals to be amplified. We have a device to adjust signals for this type of machine, but recently it's broken, smashed. This is an appropriate project to teach you about input. Smashed. Blah, 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 blah. Okay, objective. Create a working design for this product. Okay. Okay, so we're going to put down our MCU here. So there's a sample control input, and then they want an amplified control output. So we can put the control input up. Doesn't like that. General purpose I/O, and then I think that should work. And then we need to look at the machine code. So I've got it here in another window. Let's fetch it over. So we need to read. So we can set the output. We know the move 100. Okay, so let's just try that for now. Anyway, move. Okay, that's what turns on and off the outputs on the output pin. Let's see, how do we read? And there's obviously sleep if we want to do a sleep. Might not need that. So I'm having trouble switching to the data sheet view. There we go. So we need to learn how to read. So there's a touch activated light controller. So detect a rising edge in touch. So it's actually programming the chip here. So I don't know what this tech AX0 does. Plus tech P0100. By the way, the moving the output to P1 of 0 is off and 100 on, but it's a digital to analog converter, so you can have different output levels. That's why it's got a number. Right, let's see. Program structure, conditional executing, registers, basic instructions, basic arithmetic. Okay, so here's your microcontroller. Oh, it's just got different variations of that. So X bus seems to be this communications bus between them. Fine. By the way, this is on Steam right now for £10.99 if you're curious, if you're game curious. Stepper motor controller, data packet reverse. I might print this. It's only 47 pages. Data packet generator. Denver timekeeping. This is beautiful. Hey, ZX Renew. Can we check this out? This is a beautiful game. Oh my word. They've put a lot of love into this. I love how they have the dodgy, dodgy Far East data sheets. Look, the dodgy Far East data sheets which don't really tell you what you're doing. My word. Okay, look. I'm going to go through... Oh, look, they've even got, photocopied. This is wonderful. This is a beautiful work of art. Right, okay. Well, I need to know my instruction set. Oh, hang on. I do like this. Look how you have this. If you randomly search through this bundle of documents, you get little snippets like this reference card just dotted here. A bit of an email, a bit of something. This is really clever. Visa application form for the People's Republic of China. Okay. Sorry, there's a bit of hunting. I do have to hunt through this. So I really need to figure out. So it's got this code here anyway that they're sort of reading. I think we'll just copy it in. But I think they're setting up the MCU to have a rising edge detection here. Store the move P0 to ACC and select one. So ACC, does that have the value? Must be. Maybe ACC is a register in this game. Anyway, let's just battle on with it, shall we? We're not going to learn. Oh, ACC. There does seem to be some sort of internal register for that. Okay. So we want to go tech. I could just be bloody coding a real game. But where's the fun in that? So they've got plus. What the plus is? That's an interesting one. P0 100. So I think that's detect the rising edge in the P0. So anyway, let's just play. So you can see the pulse coming in on the control at a level 50, and we're doing something, but we're not doing anything with that. That's fine. So Abdul Hadi, this is a electronics game. It basically, if you want to do stuff like part of my day job, as it were, designing electronics, a lot of it is spent doing these same things, looking at data sheets, figuring out how to hook this stuff together. So this is a bloody good way of just getting going, to be honest. And you see on the right hand side here you have your bill of materials that you can choose from, and you know the total cost of your product is adding up, you know, as you're adding stuff. So it's really cool. It's just literally kind of like real life. You've got to wire it all together. So now once they've done that, they've said move 1 into register X1 for some reason. Oh, the move 1 X1. This is this internal communication bus. So it's got like this spy bus. Look, X0 and X1. That's what the move 1 X1 on their example was. But then what they store... I've got it. I can see exactly what they're bloody doing now. So when they say move P0 into AC, right? So they're taking the value. So if we step through this... Yes, you can see AC now. See AC has a value here, 25 getting stored in it. Beautiful. That's what we want. So we don't really need to store it, but I think that's fine. So we're reading from P0. So register P0 is containing the value of the port. So that's cool. We don't really need to sleep. We're just going to emulate exactly that. So where we say move 0 P1, and we need to get a jump instruction. So we need to do an arithmetic. Yeah, from JLPCB. Hey! How do you pronounce it? IPA. You think you've got it, basically. Load P0 into AC, multiply AC with some value, store AC in P1. Now, what I was going to do, I was going to compare P0. I want to do a compare Z0 to just being on or off, yeah? So if it's on, I just want to set the output on, and that I can set the output at 100, whatever I want, right? I wouldn't necessarily do the multiplying. It doesn't seem like it's needed. Now there were some arithmetic, I think. Once we learn those couple of instructions, you see, we'll just be able to battle through this. It shouldn't be a problem. And if you look on my one of my GitHub pages, I actually have a whole virtual machine that I created exactly like this with any instructions. So once you get familiar with the instructions, it shouldn't be a problem at all. So meanwhile, back on the farm, they've actually got a nice loop here. That's pretty sweet too. Okay, where are the registers? So let's just read it real quick. AC is the primary general purpose register used for internal computation. All arithmetic operations implicitly use or modify the value. DAT is the second register. Okay, so that's on the different chipset. Pin registers, so that's just reading or writing directly to the pin. And then null is a pseudo register. Okay, that's fine. So, no instructions. We've got a move and a jump and a sleep. Add, subtract, multiply, not. Okay, so we might have to use some of these. Oh, tech is test. Look, test if the value of the first operand is equal to the value of the second operand. So this one, this test AC0, it's not needed. We don't need it, do we? We're going to say test P0. We're going to test P0 is... I want to test it if it's greater than 0. So TEQ, test equal, right? So we're going to change it. TGT P0 greater than 10, for example, because we saw it bounces around. So I think we saw if there's a plus, I think it means if it's doing that, then run the next instruction. So the next instruction would be mov 100 P1, which is what we want. And actually here we can do mov 0 P1. A little. How do you do an else? Again, just go okay. Oh, I see. The effect on plus instructions. Oh, okay. This is weird. So what they're saying is, this is like the OR. So after the comparison, you have plus instructions or minus instructions, and there's a truth table. Again, I'll show you in the data sheet. You can see there's a truth table right here. So it's saying the effect on the plus instructions is here, and then there's an effect on the minus instructions. So, okay, it's a little bit out of the ordinary, but it's its own rules at the end of the day. If you're coming up with your own virtual CPU, you can make it run however you want. Let's see what it's doing. Part is not sleeping, so it's just stop. ZX Renew. I'm waiting for actual stuff to come from China. I'm getting quotes on stuff, so yeah, I could be doing something for real. Oh, you're right. You're absolutely bloody right. The output signal isn't just a 0 or 100, it's just a multiplication. So it's even simpler, right? I'm really screwing up here. You are absolutely right. I am really screwing up here. So move P0 to AC. You're right. You're absolutely right. We got there. Corona delay. Yeah, corona delay. Exactly. Oh. How do we multiply? Again, reading the data sheet on the other side. Add, subtract, mult. There is a multiply. Mult. I'm just too many operands. What? Multiply the value of the first operand by the value of the AC register and store the result in the AC register. Am I losing my mind here? Multiply the first by the value of the AC register. Okay, so we have to do something else. Move 25 AC for argument's sake, or 2. Do you think it's 2? Anyway, yeah, I just want it something. Let's see if that works. If we step, so 25 is coming in, and then the AC turns into 50. So we're doubling it. Okay. So now AC contains what we want, and then we want to move to P1 AC. Is that right? Move AC P1. Move from AC to P1. Let's get them the right way around. Part is not sleeping. Does it need a sleep? Oh, boom, boom shakalak. We're getting there. My word. Time for a coffee. I like the oscilloscope trace at the bottom. It's really cool. So I should have read the problem there. Looks good, thank you. Please enjoy a game. My daughter is learning programming. She completed a card game. Card game? Okay. Objective, win a game of solitaire. So let's see if we go back home. Do we find this? Oh, look, there's a solitaire. Oh my word, what kind of solitaire is this? I don't fancy playing card game right now. I'd rather let's keep on the CAD designs, shall we? Diagnostic pulse generator. Button is a simple input connected to a button. Pulse is a simple output connected to electronics. When the button is pushed, generates pulses as indicated in the verification tab. Okay. Let's see what we can do with this. This is now, you can see here, it's using a lot of different stuff here. So I'm just laying out some stuff for fun because the implication is it needs more than one MCU. And I think these are to allow you to put wires underneath things, yeah. So let's remove them again. So we have to look up the M6000 data sheet to see just at a high level what it's giving us. Okay. So we've got an additional DAT register here, which is nice. We've got 4 communication bus IOs, X0, X1, X2 and X3, and then we have a P0 and P1 simple IO for it. 14 lines of program memory. Ooh, it's a beast. Okay, so we're just going to read the button. No. No. It's a bit clunky, to be honest with you, moving these things around. Should be okay. We just want that. So move the value from P0 to AC. They really want this part to sleep right, which is kind of cool. You kind of need that in real life, as it were, because you need to allow the little RTOSes and stuff time to relax. Okay, so that's good. So AC is representing that, that's fine. So what it's saying, I'm just looking at this diagram here. It's expecting to sort of create this pulse output. I'm wondering why you can't do it in the part you have, but you've only got 9 lines of programming code, so it's probably for that. Just a quick look through this list on the right. Lots of snazzy parts, but I wish it would say what this bridge part was. Okay, so let's have something here that generates a pulse then. I think that was the output. Is that right? Here we go. Move, what was that, P1? Move 100 to P1. So that's the pulse. So you can see we should be generating in red on the bottom. You can see where the pulse generator is working, but it obviously shouldn't generate a pulse all the time. So we need to have that while. I think that will do it. And we had an if TEQ, yeah. TEQ X0 1 pin is not connected. Yeah, that's fine. We'll connect you up. Boom. Do one module that generates the pulses and one that only connects the output if the button is pressed. Yeah, that's what we got here going on, I think. Part is not sleeping, blocked on read. Just trying to hook up the parts. Oh no, X1. Part is not sleeping, blocked on read. Okay. Also, when you're doing real life coding on these, you've got to be careful of your interrupt code, so you don't try to do too much within an interrupt vector. Part not sleeping, blocked on read. I don't even know what you mean. Okay, so oh, okay, interesting. I'm not sure. I'm not sure what we see on TEQ, to be honest with you, when it's running. How do we inspect that? So we just need to check out real quick what the COM bus does. How does that work? Maybe split the work. One chip always doing pulses, always doing the AND of your input and the pulse train coming out of the first chip. DevJock, you could be right there too. I wonder if there's loads of ways you could solve this too. Or I say loads, but a few different ways. Your way might actually be the solution, but I feel I need to understand what the X-bus works. How does this X-bus... The X-bus system. I definitely saw something here about the X-bus. Come on. X-bus. Oh, I see. X-bus values are discrete data packets from -999 to 9 inclusive. X-bus pins are marked with a yellow dot. Oh, okay. So it actually sends a byte. I say a byte. More than a byte. It can go to 999. Fine. So when this is actually running though, in this example, it's actually getting 100. So if we wanted to just put, I know we should just have it, if we change it to test greater than, it would just work, I think. Oh, okay, we're kind of there. We see the riding edge part here, but now we have a part not sleeping, blocked on right. DevJock, have you played this game? It might even be easier. Use mov x0 to p1. Oh, literally just move x0 to p1 and then just sleep 1 and then 0 it right away? I don't know. Because if you, on a normal microcontroller, I think you could do that, because as long as the sleep's not there, that would be so infinitely smaller time during the switch. It would probably just work. I'm just curious though, I would like to understand though about this sleep thing, on why, you know, it says part not sleeping, blocked on right. You know, what does that actually mean? Is it because move? Should you just be doing that? So you're using ACK as a kind of a buffer, double buffer, so it shouldn't be waiting on that? There's something fishy. Or is it to do with that digital bus? Maybe the digital bus has to be serviced. Let's just check up blocking on the data sheet, otherwise we're not going to get anywhere. Otherwise we just, what do we call that? Is it, what do you call that? Coding through messing experimentation? You know what I mean? When you just keep messing around till something works. Non-blocking buffer, look. Ooh, there's an internal non-blocking buffer on that component. 4 non-blocking X-bus pins. So there's nothing in the datasheet about blocking, unfortunately. I like how it's telling you to set up your dividers for all of these documents. Is that right, shotgun program? I don't like it, DevJock. I've seen coders who do that. They just keep messing around till something works. And I know this is a game. But if they're, yeah, and they're not really giving us the information on that. Oh, hang on, it does say. Okay. There is something here. Okay, they explain it. Let's bring it up. Look at this at the bottom. Simple I/O pins can be read and written at any time, no regard to the state of connected devices. However, XBus is a synchronized protocol. Data over XBus pins is only transferred when there is both a reader attempting to read and write. If a reader write is attempted without corresponding operation, the connected device will block. Right, screw that. So let's just not use XBus here. There you go. We're just going to go for an analog solution then. So P0. Oh ho! Something's happening. Okay. Yeah, exactly. DevJock, it's horrible. And then you know what happens? Those kind of coders will always end up with just some really random stuff happening in their code, you know? It'll just be... Oh, okay, like me, look at this randomness happening. Okay. He says, doing exactly the same thing. No, let's go back to basics now. So we're going to move... Let's step through this. It doesn't seem to be much of a step. You really... Okay. So we've got the value coming in. I think we've got a sleep here. I think that's what's causing us a problem. But I'm not sure. Do we really need the sleep? I think it's kind of insistent in this system that you have to have some sort of sleeps going on. No, we're going to have to step through it. Okay. So we have that value coming in. So, boom. Where were we in our second processor? It's these damn sleeps, isn't it? I'm really worried about these sleeps. Now the game does not let us run without them, I know that much. And we definitely will need one because of the pulse generator, but yeah, you see, part not sleeping. But it's, yeah. In real life, you don't normally care. That's the thing, do you? And you can't sleep in a fraction less than 1. So they're doing that. It's good. It's a puzzle game after all. Scratch our heads for a second. Yeah, that's right, Winsome Hacks. Just use another framework. All right. Let's see the solution. Just the first module. Okay, let's go through the suggested solution here then. Can we do it in one module? I think is the question at the end of the day, right? Pop that here. Right, so that is the solution suggested by. Please forgive me, I don't know how to pronounce the name, but let's try it. You can see it didn't occur quite right. It's got to wait, right? You've got to put a wait in here. Okay, I got it. These will have to be here like that, right? Ha! Oh my word! Look, there you go. It's scary how like real life this bloody is. Woohoo! Let's keep going. It begins. I got us an incredible deal with a major esports personality. The Solid Steel gamer. Her contracted us to make light up signs that actually animate for her fans. As long as we can keep the cost down, they're going to want tons of these to hand out at matches. Okay. Let's do it. I couldn't have done it without you, to be honest with you, your selection on those. So, click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0, drink 1 and drink 2 are simple outputs connected to display segments to a drinking animation. Control the display segments with a fixed repeating signals indicate the verification tab. Okay. So, the first thing you'll notice is that you do need 3 outputs. Okay. I'm just going to pop our couple of different micros. So, the second micro doesn't really help you, okay, because the second micro has the same amount of I/O. So we might as well start the design with the simple one. In fact, look, how are you even going to do that? You don't have any other logic here. What do you mean part not on board? What's the point of that part if you can't use it to bridge stuff? Anyway, fine. Should we make one? Oh, we could make one the input controller, one the output controller, couldn't we? Okay. In fact, I don't like that you can't see that. I'd rather that. Okay. Julian, this is insane. This is literally, again, refreshing for Winsome Hacks and everywhere. This is a game that requires you to build circuits using fictional components which have their own fictional data sheets, and you even have your own company manual from that company with all of the visa application forms, data sheets, some of the data sheets in foreign, photocopies, different bits and pieces. It's literally like bloody real life in a game. And of course these have a virtual instruction set that you've got to learn, so it's fun. So DevJock, yeah, I suppose they are the inverse of each other, aren't they? I mean, can we step through the data? So that's the entire data, but is that really a... Would you say you just use only one of the clicks, potentially? I mean, it's doable. And if you see these outputs, the drink 0, 1 and 2 though, they do have their own interesting patterns. Okay, should we just go for the worst case way of hooking this up, right? If you were going to do this in a really cack way, because remember these MCUs only have a limited number of lines of code each, right? Okay, as well. Julian, they are. That's how it verifies it. So it gives you a trace, a sample trace of the inputs. I don't think they always have to be clocks, but in this case, the test data is showing that. Okay. Why don't we hook up the P zeros? No. How do you move him? Come on. So if you have that, this processor can definitely determine the inputs, but okay. So we're going to hook up the bus. I'm not convinced on how these wires work, to be honest with you, but okay. Oh, so DevJock, so the routing becomes an issue as well. Okay, so that's not just me screwing up here. Drink 1 equals drink 0 and not drink 2. Oh yeah. So drink... So drink 0 is the inverse of drink 1 and drink 2 ANDed. So you could do this cheaper. What I was going to do, let me work through the solution that I thought, right? I thought I was going to do the state management here, which looking, oh sorry, just bring up the data sheet on my screen again because I need the instruction. TEQ, TNZ, T. Okay, here we go. So T greater than P0 100. Mov x1 minus mov 0 x1 Okay, so let's just see that's gonna. Oh yeah, and then you need to sleep. Oh yes, do you remember this bloody digital read has a thing on it? Although yeah, you're right, you have a cheat here because you say if you're only monitoring one click, do you ignore the other? Because certainly in the data, the test data, it never shows them both to be positive at any time at all. Any time at all. Winsome Hack say, wouldn't that be a really cool way to outsource program development? You literally just are setting pieces of work. Mov. Right, so that should allow us to continue, shouldn't it? Right, so mov x1 to ACC. Have I got the whole read? I do like this collaborative effort. I'm going to actually literally cut and paste from your chat. Let's see. Oh, it doesn't let me cut and paste. Are you sure? I don't think click one and click... Oh, balls. So this whole thing is outputs. You got it. I just assumed they were stupid inputs. So Julian was totally right. He's right. They are like just clocks. Yeah, I love it. This is so much fun. No, this is like work. Okay, hang on. I gotta think of this. This is mental. Okay, this is mental. Hang on. Right. I'm gonna get rid of everything because let's just bloody do one thing at a time then. This is almost... Okay. So I'm gonna pop this one up in the corner out of the way. Is that connected? I think maybe it has to be just one over like that. Anyway. I'm not sure what's connected. We'll test this actually. So oh my gosh, the amount of times I've written bloody stuff like this in real life. Okay. Okay, I've just cocked something up a little bit here. Yeah, divot. What an idiot. What an idiot. Just because of that sleep. Have the pattern. Sleep 0. Okay, but we're starting on the inverse of what we want. So, can you use macros? Is there a pre-processor? Okay. Clocks are good. Yeah. Now, let's just do a little quick test. I want to remove... Oh, yeah. See, it says pin not connected. It really does expect... Doesn't look very pretty then, does it? That's probably going to come and bite us in the arse when we want to do anything with that digital. Okay, so we got the clocks going on. Now, feasibly, do you really have to even connect these two sides? These are totally just like clock generators, so I don't think we're going to have a problem with this. So we just got to decide, do we want to make drink 0, drink 1, or drink 2 master? So I don't think we need a big one. I think we're going to do something like this, my gut feeling. You know what you could do though, DevJock, if you really wanted to sort of cheat, you could just generate all these patterns independently, because it's just a simple repeating pattern in the simulation, right? It doesn't actually have... Oh look, the finger! The finger's wiggling. Her finger is wiggling in the thing. I don't know if you can see that. Let me just check I'm not blocking it. I kind of am blocking it. Ooh, there we go. Look at her finger in the little window. Nice. We got a finger wiggle. So, but yeah, let's just work on the first one then. So, drink 0. So, mov P0, mov 100 P0. Sleep for 1, 2, 3, 4, 5, 6. Mov 0 P0. Sleep for 4. Let's see what that does for us. We got something going on. I'm just thinking of something. Hang on. Sorry, I'm just umming and ahhing. The reason I'm umming and ahhing, I'm kind of like thinking, can you do this? I think the problem is, I think drink 0, this one has to be the drink 0 output. Unless we try something. I just feel that, remember that whole anding and oring, that drink 0 is the output of a couple of different ones? We might... Is he overthinking it? He probably is. Okay. Before I start overthinking it, let's just mess around a little bit as if you were trying. You've only got 9 lines of code. I think that's your problem here. Let's for fun, let's make 4 discrete ones. You're just trying to do the game, right? You're just trying to do the game. So let's work on drink 1. Mov 0 P0. Sleep for 1, 2, 3, 4, 5, 6. Sleep for 6. Mov 100 P0. Sleep 1. Mov 0 P0. Sleep 2. Mov 100 P1. sleep 1. Yeah, I'm just wondering if you can trying to be too smart with some stuff, that's all. Yeah, see? I think you have to, just looking at this. I don't think you've got the resources. It's lame. In real life you'd be embarrassed at this solution, right? But that's why it's a game. Sleep 7. Then it's on for 2. It's off for 2. Right, should we do it? Oh, almost. We've got a cumulative error here because we've got a sleep 2. This is so cool. This is literally the best game I've ever seen. Woo! Production cost though, a little bit naughty. So DevJock, I'm not going to do it now because I just, it's a stream and we're just trying the game. Literally downloaded it, but it does encourage you to want to try to do better, doesn't it? Because I kind of think with the other MCU that had more lines of code, you might be able to do something else with it. Just one thing though, I'm just going to do continuing. Do you see on the right hand side? I think those other items that were there were locked for us, these DX300 and stuff. I'm going to return to mail. I think I think there are some other components that will help, I guess is what I want to say on this. So what's this one? He owns a brand drinking game. Scorekeepers. Okay, let's try that one. Oh, wow, look at that. It's beautiful. Oh, I kind of wish that real stuff was like this, right? This is like kind of what Arduino would want to be. Right. Point and Fowler R inputs. So finally, displays an X bus display. The counter should keep track of the count. When point is pushed, the count should be incremented by 1. When Fowler... Okay, so... What's this thing? Note. Oh, that's literally like a message. Oops. Could it be that simple? So if P0 yeah, 9 lines of code. Hang on, we need to see the we haven't used a command for arithmetic. Add. Add 1 to ACK. Add 1. Add the value of the first operand to the value of the ACK register and store the value in the ACK register. Okay, that's fine. I love that. The sleep here is because of the power. If you don't have sleep... Okay, so when do we output? Let's read what you're supposed to do. Not below 0. How many lines have you got? 1, 2, 3, 4, 5. Oh, we should be able to do it. So if come on, I want to say if AC is less than, oh, here we go, TLT almost. So what was happening? TGT0 AC before sub 2. Let me just step through it though. I'd like to understand why it's going wrong. Where's the bit where this went wrong? Oh. Okay, so I obviously... Why am I subbing 2? Why am I subbing 2, guys? Hang on, let's start. I'm gonna wipe some code. So let's clear this out, okay? That was what we had before. And the reason it's not working is because we're going under 0. Oh, because if you foul, you lose 2 points. Okay, sorry, I'm a dickhead. Yeah, sorry. You get me. But not below 0. Okay. Okay, not quite right here. Let me see what I've done wrong here. Let me see what I've done wrong here. Actually, why are we registering at point? What's P0? Hang on, we should be not getting anything on P0. Have I got these the wrong way around? Yeah, divot. Oh, I'm loving this game. I really wanted to go and do something else because, you know, it's family day and I've got to do family stuff, but I can't help myself. Just check my email real quick on my phone to see if there is anything super pressing. Your Amazon order. More electronics, by the way, in the post. If you haven't seen today's video, I'm buying way more. So we'll be able to do this in real life pretty soon. Okay, so what's this saying? Is there a new revision? A new design? What? Hang on. Let's go back a sec. So you can make a new design. Everything's the same, but look at this on the right. I don't think there's a way of making it cheaper. What's the prequel? Is the TIS 100 a computer? What have we got here now? Okay, so that's like a pulse generator. Let's see. I'm curious. See what this does. Should we just play with it? Don't like it. Let's not worry about that for now. Right. We'd have to look at the data sheets for this. So that's an analog to digital converter. No way. Diode. So it's giving you a few kind of logic blocks here. Oh, and there's different CPUs, is there? What's the difference between that one? This one might just have more lines of code in it. Right, before I get carried away, what was the actual... Oh, was that just it? Objective complete. Oh, okay, so that's done. Rubbish audio thing. Okay, let's look at the audio thing. Audio in inputs is connected to an audio source. Audio out is to a receiver. Maximize is a simple input connected to a switch. The signal from audio in should be copied to the audio out, applying harmonic maximization. Harmonic maximization. Okay. Here we go. There's a formula here. Why is it not letting me cut and paste from the data sheets? Okay. I thought I wrote out the equation here, but... Oh, you bugger. Times 4 plus 50. Can you put this anywhere? Yeah. It's weird it doesn't have word wrap. Anyway, okay. I love it's got this audio trace here. Nice. So I'm guessing these are capable just realising there's not any other parts at all, apart from these not recommended ones. So you're saying you should be able to do it without that one. Yeah, I get that, DevJock. It's awesome. I'm very intrigued by this. So mov p1 p0. Am I getting my operators the wrong way around again? Yeah. I'm just wondering something here, just for fun. Okay, so it doesn't like that. I'm sure it might let you like that later. See you in a sec, DevJock. I love the digital bus here. It's beautiful. Right. Good. So just to simulate, by the way, so all the logic, calculation logic is going to go in the first block, which may be necessary to replace with one of these if you don't have enough lines, but just to sort of prove the point, I'm going to so when when the button is pressed to maximize, we should see this flat lining on the bottom. Step through that's not quite doing what I expected. Again, getting these arse about tit. I don't. Hey, Becky. Yeah, that's what we want. It depends. Like so a lot of these. This is letting you put registers and values in either column, which doesn't feel right to me. Normally, the assembly languages I've used are pretty strict on that. So that's kind of a gotcha on that one. Anyway, that works, so clearly we can detect when that's on. So when that's on, we want to implement this audio in minus 50 times 4 plus 50 stuff, so a bunch of stuff here. Okay, so we want to, I'm just going to bring the data sheet up again in my other screen. Arithmetic calculations. Here we go. So we want to sub Sub 50 P1 or sub P150? No, just sub 50 from AC, I guess, plus mov P1 to AC, sub 50, mult 4, add 50. Uh-oh. Uh-huh. Mov X1. Oh, interesting. Getting there. Right, let's see what's happening here. So AC has 100. It's minusing 50. Just multiplying it by 4. Okay. Moving it to the output buffer. It's red. Okay, hang on. I think we have a scaling problem, don't we? Let's check this harmonic. I'm just trying to check that the order of the calculation makes sense. I don't think there's a problem. Idiot, 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 idiot. There we go. Woohoo! This is great. If only life was like this. Okay, but look at the lines of code. It's suggesting if you can get it down a bit. Anyway. Wow. Alright. Well, I think that's probably enough of this game. What a wonderful game. I think you'll all agree that this is definitely worth playing, and thank you all for everybody who helped me through it. We're going to be streaming this game again, no doubt. I think it's definitely worth picking up. ShenZhen. That is bloody amazing. Thank you so much for spending some of your Saturday with me, and thanks to everybody who's helped, and thanks to everybody who's just watched and not helped. All the best. See you in the Discord. Let's talk about some real electronics soon. Bye bye.